Let us factor when the leading coefficient is not a 1. First, let's check to see if this quadratic trinomial is a perfect square by multiplying 4 times 81. Now, we'll take half of 36, which is 18, and square it, and it checks. 324 is equal to 324. 4x squared plus 36x plus 81 factored is the quantity 2x plus 9 squared. A more detailed check is to take half of 36x and square it. We will now check it with the first term times the last term, and it also checks. Let's take a look at another example. First, we will check to see if the quadratic trinomial is a perfect square by multiplying 9 times 49, then taking half of negative 42 and squaring it. It checks. 9x squared minus 42x plus 49 factored is the quantity 3x minus 7 squared. A more detailed check is to take half of negative 42x and square it. Check it with the first term times the last term, and it checks. Let's take a look at another example. First, let's check to see if this quadratic trinomial is a perfect square by multiplying 36 times 25. Then take half of negative 60, which is negative 30, and square it. It checks. 36x squared minus 60x plus 25 factored is equal to the quantity 6x minus 5 squared. A more detailed check would be to take half of negative 60x and square it. This will leave us with 900x squared. We will check that with multiplying the first term times the last term, and it checks. Let's take a look at one more example. First, let's check to see if the quadratic trinomial is a perfect square by multiplying 25 times 16. Next, we will take half of 40, which is 20, and square it. It checks. 25x squared plus 40x plus 16 factored is equal to the quantity 5x plus 4 squared. A more detailed check would be to take half of 40x and square it. Check it with multiplying the first term times the last term, and it checks. The given expression represents the area. Find the side lengths of the square. First, let's check to see if this quadratic trinomial is a perfect square by multiplying 100 times 121. Next, we'll take half of negative 220, which is negative 110, and square it. 100x squared minus 220x plus 121 factored is the quantity 10x minus 11 squared. Each side length is equal to 10x minus 11. Let's solve by factoring. In this particular case, the leading coefficient is a 1. Let's use some mental math. We are going to take half of negative 10, which is negative 5. Negative 5 squared is 25, which is equal to the first term times the last term. X squared minus 10x plus 25 factored is x plus 5 squared. We're going to set x plus 5 equal to 0 using the zero product property. Subtract 5 from both sides. X is equal to negative 5. A more detailed check would be to take half of negative 10x and square it. Check it with multiplying the first term times the last term, and it checks. Let's solve by factoring when the leading coefficient is not a 1. First, let's check to see if this quadratic trinomial is a perfect square. We'll take half of 42, which is 41, and square it. It's equal to 441. Which is the same as 9 times 49. 9x squared plus 42x plus 49 factored is equal to the quantity 3x plus 7 squared. We'll set that equal to 0 and use the zero product property. 3x plus 7 is equal to 0. Subtract both sides by 7. 3x is equal to negative 7. Divide both sides by 3. X is equal to negative 7/3. Let's take a look at a more detailed check. 42x divided by 2 squared is equal to 21x squared, which is 441x squared, which is the same as 9x squared times 49, which is 441x squared. This concludes the lesson for today.